Here we're going to take a look at slopes and parallel lines, and we're going to do this in two different ways. We're going to start with just a very simple two parallel lines to start with. And on these parallel lines, I've marked some points, A, B, C, and D. Now what we're going to do in order to prove these two lines are parallel, although we're saying it, but what we're going to do to prove it is we're going to go ahead and put a transversal in straight through. Now what I want to be able to do is I want to be able to put a 90-degree turn from here to B. So what I do is if this side has a specific length and this is 90 degrees. So I'm just looking at this triangle to start with. Well, what I would do is I would use the same distance from C away to make my perpendicular up to D. So I'm just really starting with a triangle. I'm ignoring this little bit and these bits because I gotta kind of imagine them away to just see these two triangles. I want to talk about them as if they're on a coordinate plane, although we're looking at them here where they're not. What I know about two parallel lines with a transversal is I know that this angle is congruent to this angle. At this point, I get to have an angle, side, angle, triangle congruency with my other triangle. This is convenient for me. And what it means is that I'm able to say that once those two are there, the two triangles are congruent. Just by having congruent triangles, I know that corresponding parts of congruent triangles are congruent. So what I'm going to do is I'm going to say the slope of this line here M, is equal to this length, BE, over this length, AE. So I'm still looking at rise over run. The slope of this line is equal to DF over CF. Again, using that same rise over run idea. So if we're trying to say that both of these are having the same slope, then I should be able to set them equal to each other. So that's what I'm going to do. I'm going to say that BE over AE is equal to DF over CF. Now I'm going to multiply both sides of this by AE. When I multiply both sides of this by AE, I get BE is equal to DF times AE over CF. This doesn't seem immediately helpful, but what I want to remember is that when I set up my triangles, I said that AE was congruent to CF. Now this was a condition that I used to build these triangles in the first place. So I'm going to substitute AE in here so that I get BE is equal to DF times AE over AE. So I can cross these two out, giving me BE is equal to DF. So I can see that my lines wind up being a parallel. It's all coming back to this angle side angle, the building of my two congruent triangles. And this is all because my angle here, my BAE and my angle BCF are congruent to each other. If I went to try and look at it on a coordinate plane, which I didn't put in my x-axis, and all I did is I built on some points here. So the thing I'm going to do is I'm going to start by just simply establishing what these points are to make it easier to work with. So I get a negative 3, 4. I get a 1, 2, a 3, negative 2, and a negative 1, 0. So I'm going to label these points, making it easier to talk about them. And I'm going to label them just simply A, B, C, and D. If I know that the slopes of parallel lines have to be equal to each other, then what I want to do is I want to go ahead and find the slope of AB. The slope of AB is equal to the change in X and that change in Y. So I'm going to do the change in Y, 4 minus 2 over negative 3 minus 1. So AB is equal to 4 minus 2, which is 2, and negative 3 minus 1, which is negative 4. So we simplify to get negative 1/2 as my slope for AB. All I have to do now is look at the opposite side. I'm looking to see, are they going to be parallel this way? Because this will allow me to use this later on with parallelograms. So I can say that CD is equal to my change in Y, 0 minus a negative 2, so plus 2, over negative 1 minus 3. This means that CD is equal to 2 over negative 4, or CD is simply negative 1/2. So I get that my two slopes are in fact congruent to each other. When they're the same, this is the thing that we learned well back in algebra, that parallel lines have the same slope. The reason very simply is to say at any point on this line, if I chose when x is negative 1, it is going to be the exact same distance from my DC line as it is from my AB line. Remember, math rocks with a capital M.